Finding DeFi, Hackathon, Morales and Google. Defining DeFi, Hackathon, Morales and Google. Defining DeFi, Hackathon, Morales and Google. Defining DeFi, Hackathon, Morales and Google. 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 Define Hackathon, Morales and Google. Defining define Hackathon, Morales and Google. Defining define Hackathon, Morales and Google. Defining define Hackathon, Morales and Google. 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 Morales and Google.
Greetings, developers and hackathon participants. Welcome to another Defining DeFi live stream workshop event. We're joined again by Vic with BNB Chain, and we're going to go over building secure Dapps on BNB Chain. Vic, welcome to the stage. How are you doing today?
Thank you, Phil. Thank you for having me, and thank you all for coming. And I'm very grateful and honored to be here in the Morales and Google event. So let's, I guess, like a little bit introduction. So I'm Vic from BNB Chain, the senior architect from the R&D team. And today we are going to talk about building secure applications. In our case, decentralized applications. And we will talk about different aspects about how to make sure that your application does not become both like a threat to your users, and also from your business perspective, you don't lose money. So let us start.
I've got your slides up on the screen now.
Cool. So our goal in the development and in the blockchain sphere specifically is to accelerate the live on-chain security. And this is both for the Web3 users' interactions, growth, and as well as applications community. And when we talk about DeFi specifically, I want to mention that and to stress that DeFi is the #1 target. It's not only because they are actually making money and like in terms of managing monies, but it also in terms of their different variations of DeFi protocol, it's somewhat easy to create exploit schemes using some kind of derivatives or lending protocols. So specifically for the DeFi protocols, like the night is dark is full of terrors. And a little bit of about the facts. So bridges only in this year alone accounted for almost 70% of total hacks. So, and you as a DeFi protocol will most certainly use bridges because the management of assets usually involves both ramping solutions, like putting real dollars into the system and taking them out, but also to interacting with other protocols, maybe with non-EVM, even like with Solana or the Cosmos network, or even within the EVM community between the BNB chain and Polygon and others. So all these interactions essentially provide a weak spot for exploits, and these are the top solution components that are targeted. On the overall scheme, we are talking about immense losses. We are for the last several years, almost $2.5 billion have been hacked from the DeFi protocols. And what is interesting that over 97% of all crypto is stolen from DeFi. So this is why DeFi is the top target. So while there are different projects in the blockchain space, most of the hacks are in DeFi protocols. And the way it currently is, and most likely will be, that 98% of hacks occur within like very limited time span, and the team and the founders don't usually find the time or capability to react to it. It's either done during weekend, during nights. The attackers make a social profiling of the team and with the time zones, and essentially find the weakest spot in terms of the team like being actually awake, and also like from the response perspective. So maybe it's like they know exactly that the team may be at some kind of event or some kind of offsite gathering. So these are the known facts and known events that you're being targeted. And so eventually, no matter what you do, this is the time that you'll be hacked, when you are the most vulnerable. And interestingly, majority of the attacks could be even avoided. So these are the attacks that relate to code quality, and naturally there are some kind of interesting in quotations, of course, exploits that look into like the basics of the basics of cryptography, and something that even after several security audits you won't be able to foresee. But if you follow some kind of like a common set of guidelines, then from your perspective, your project will be already 10 or even 100 folds more secure than the average DeFi project. And this is like from several reasons. A lot of it around just lack of expertise in terms of DeFi space, lack of expertise in the Solidity language, lack of expertise in the EVM specifics, like how it actually works. And also it's like you generally also hire like young developers who are excited about the DeFi space and the blockchain in general. And these are unfortunately people who don't have a lot of experience in terms of writing quality code. And when we say quality code, it can be even Java code, C++, or even JavaScript. So essentially any code development, code management practices, things like this. And so we'll talk today, we'll put like everything that relates to DeFi a little bit aside and the blockchain, and we'll talk a little bit about how do you make your Solidity code more secure. And hopefully that will ensure that you will make at least very hard for the hackers to exploit your project, and they will better else go elsewhere. So from your perspective, this is something that you definitely need to make sure that you, either as a R&D leader or as a business founder, follow up with your team and stress on this. I listed here some of the most common exploits, and as you see, this is something like very trivial, like something that uninitialized variables, functions that allow anyone to destruct the contract, multiple contracts, constructor schemes. So these are very, very basic stuff that can be avoided. There are more. Naturally, there are different attack levels and attack vectors, but today we are talking about the code, we are talking about the deployments and keys management, things that like something like a very low hanging fruit, like very low, almost on the ground. Just take it, pick it up, and that's it. So developing secure code. The first thing is, of course, don't reinvent the wheel. And standardization is something that is very, very in the roots of the software development, either using the known design patterns or the GAN of 4, or by actually in the DeFi space or the blockchain using the libraries that are commonly used. And there are several, but it seems like OpenZeppelin, which is also an open source, is taking the lead in terms of market share and in terms of different like coverage of different topics. So we definitely take a look at the OpenZeppelin contracts, either from contracts, actually like how to make a token. We discussed about the tokens during the previous workshop. So these are the contracts that you'll be building, and use OpenZeppelin as a standard or as a like derive your contracts from these contracts. We have also safe math, so things like overflow. We'll talk about it a little bit later, but this is a good set of libraries just to add different numbers. Upgradability of your contracts, gas station, and meta transactions, which are somewhat related to one another. It's when you want to either to use some kind of variation of gasless solutions and take part of the gas upon yourself from the users. This is very good from the growth aspect and allows better integrations of users to the platform, and also different some kind of aspects. There are more and more of features, and these grow every day. So definitely follow the guidelines. Definitely look at what kind of contract they provide. Read their blog. Everything is open source. Just clone it, fork it, extend it, do whatever you want, but use something that has already been verified like over the years, and multiple audits and multiple variations of different hacks. And so after each hack, specifically if these contracts have been involved, the patches are integrated into the code. So from your perspective, you are getting like the best of the best in terms of this like sort of like basic blocks, but sometimes these basic blocks, if not done correctly, essentially impair your capability of building your business model and your much more like unique business case. Static code analysis. And we will talk about several tools, but the main theme today is these tools already exist. They are open source, they are free. There are some tools that are paid or have some kind of restrictions on them. We won't be talking about those, as we want to cover the general audience, and also like the smaller, like garage startups, which may or may not have funds to invest in the security, although this is like probably the most topic that you want to invest. But even if you don't, we'll discuss today the open source features which are ready for you, and you can use them, and you should use them. This is something that is like, not using these features, there is no excuse. And the first one, we'll talk about static code analysis. And so what it does is essentially scans the Solidity code, scans your Solidity programs, your contracts, and finds vulnerabilities within, like, it's a command-based tools. So you run it on your code, and it finds like it's like essentially like a compiler, but more oriented on the security. So it finds different aspects of the code that can be improved, and also provides more visibility to what you have built. And the most important thing, so this can be integrated in the development process using like Git hooks and this kind of stuff. So this should be configured to run as frequently as possible, as essentially this doesn't cost you money. There is no API, there is no usage costs. So put it to the most frequent run, so that later on, when you are stressed to deploy, you won't end up with hundreds of bugs that you need to fix. And naturally, this is something, then it's a problem. If you find it or catch it in the beginning, then you can streamline the secure code development at the roots. And this is very good practice from the R&D perspective, and also when you build the company, when you build the R&D team, this is something that should be standard within the team also. So let's talk about different features of Slither. And as I said, it provides high visibility of the code. So essentially what it does, it works in a sense of, it has like summary printers. And what it does is each printer have like a different functionality. So for instance, Initial is a contract summary printer, which just gives you the overlay of your contract, both in terms of visibility or accessibility, like if it's public, if it's private. And why it is somewhat simple when you have hundreds and hundreds of lines of code, you lose track of what you have actually built, and this like reduces all the fluff and all the documentation and all the actual implementation, and only prints signatures that you have for the specific contract. And then you understand from your perspective who has built it. You may ask, like, why is this private? Why it is not private? Things like this. This is the simplest, but this is very useful. The second one is function summary printer, and this is something that gets a little bit deeper. And what it does, it shows who can write and who can, like in terms of what each method does. So like both from visibility, if it has different modifiers, such as like is owner, like this kind of stuff, so that owner can access it. And it also, as you see, shows that message.sender is being read during this method. And and also if you make other calls to the other methods. So this is also like provides like high visibility of what your methods actually do in terms of interactions with the other parts of your code. And then you can see if this is something that is normal, or essentially look from like higher perspective without actually understanding what the program or the function does, to look at how it interacts with others. The two other printers which Slither provides is inheritance, essentially building an inheritance tree of what your contracts how your contracts are relate to one another. And so this is also useful when you override different methods, or when you inherit your contract from something that should be avoided or could be avoided. So essentially limiting the functionality of the contract, or extending it if something is not inherited correctly. So these are very good tools, like to look at the bird's eye, so to speak, to understand how your entire program is built. And especially in the case of smart contracts, because usually these programs are not big. So they have several contracts, maybe even several dozens, but it's not something like a million lines code base. This is something that can be printed out and can be visualized. Ideally, you print it like on actual paper and hang it on the wall so that everyone can see. And this provides also like better communication both between departments and others. And the last one I will talk about is authorization printer. And this is very important for the hacks, and something that should be run for sure. This is essentially who can send different messages, who can access different states, and who can call your methods. And this is very important because like for instance here you can see that only owner can call the constructor. And so this kind of stuff are seen here. And for instance, if you're looking at the mint method, then it uses the balances variable and it writes into that. So you can also see what method, how it interacts with different state. So this was one tool. And now let's talk about testing. And testing is somewhat like sort of like theme that you don't expect to talk about, because in a way everyone says that they are testing their applications, but in reality, though, you don't. And this is even though if you're having unit testing, usually you have like one or two use cases, which from your perspective you cover usually like the happy scenarios, which always pass. Maybe you also make some tests around to make it not pass, but you don't really test different scenarios. And what we'll talk about is property-based testing. And this is general testing techniques which are available in any language. So this is not something proprietary and unique to the Solidity or smart contracting. This is something that can be used on any language, and different frameworks exist in all the languages. So if you use this technique, this can also be ported to your server-side code, to your front-end code. This is something that is very important. So what it does essentially is it checks the truthfulness of the property. That's it. And it does this essentially by making different variations of the input and checking if the condition holds. So for instance, if we talk about strings, so A, B, and C, so we want that A is a substring of A plus B plus C, plus is a concatenation. So this is something like natural. So if you concatenate three strings, then one of those is a substring. So you define this kind of conditions, and then you just run it, and the tool that was built for property-based testing is actually what it does. It runs like thousands of different variations, a random input. You don't have to invent your input. It just you need to explain what the type is, and then the engine creates different random values, both for strings, for floats, for integers, for anything. And in case the conditions don't hold, then the tool will give you the example which failed your program, and also for retesting purposes, it gives you the seed, like for random generation, to be able to rerun it again. Because if you have like dozens of different attributes, it will be difficult like to write them down and actually redo it on purpose by yourself manually. So it also provides the seed to rerun that specific generated scenario. And if we talk about Solidity code, the tool called Echidna. And so this is a property-based testing framework for the Solidity functions. And so you have to define this. We'll get into example later on. So from your code perspective, you have to define these methods. It shouldn't have arguments. It should return true if successful, and should start with the name Echidna. And as this tool, what it does is automatically generate arbitrary transactions to test the property. And this is important because here we are talking about smart contracting. So instead of just making a call to your functions like unit testing do, the framework actually makes on-chain transactions. So this is useful to to end-to-end testing, to see how your program or your smart contract interacts with the chain itself. And we'll see, as usual, like it will show the what kind of use cases fail, and other features. So if we have, for instance, we have the contract, which has like token, and it has several methods. It has airdrop, which just gives the user 1,000 tokens. And you have two different methods. One is increases, and the other is decreases the balance by 1. So you derive your contract from the token and call it like test token. The naming here doesn't matter, but the naming of the method does matter. So as you see, there is a method called Echidna balance under 1,000, and you want to check. So for instance, you have a business rule that no user can have more than 1,000 balance, for instance. And if you run the tool, then essentially it will tell that in order to hack your business rule, you need to call the airdrop and then backdoor. So you see here a printout from the calling sequence. And so essentially it's generated 5,000 different variations of methods. So you see here we are talking about also like the different variations of calling of the methods, the order, and also of the input. So this is naturally, this is why so many variations have been created, and 1,000 whatever passed. But once it reached this specific sequence where you have an airdrop and the backdoor, the program failed. So it would be very difficult for you to write this kind of like 5,000 different use cases and test cases. And this is why this tool is interesting, and this is why it also needs to be used. Especially it's like sort of like auto-generated. Very little code needs to be written, and you just need to provide the business rules, and then it by itself generates all the needed stuff. As I said, the tool generates on-chain transactions. So naturally, someone needs to call your code. So there are several addresses that are involved in this calling. So the constructor is sent from this loan address, and on the execution there are several addresses that are used, and different variations of who starts and who ends. So like it really checks the application both in terms of one user using, but also like from the when several users are calling the contract like in different variations. So this is very useful tool to really check how the contract interacts with the blockchain and with multiple users. The third tool that we are going to discuss is dynamic symbolic execution. And this is yet another family of tools. And again, this is general practice rules, general programming rules, and they are specific tool for the Solidity. And to get a little bit deeper into what this tool does, this one actually looks into path execution scenarios. So for instance, if you have code like if a equals 65, then there is some kind of bug there inside. And 65 naturally can be some kind of like dynamic statement that is derived from more variables, maybe some kind of arithmetic logic. But eventually what it does, it will it works like a compiler, so to speak, but builds different variations of paths. So for this particular small function, it will create two different path predicates. This is how it's called. The one is a equals 65, because this is a particular if clause, and the other one, anything else, essentially something that is not 65. So this would be like a 0, for instance. And how is this tool different from the previous one? Is it actually looks at your logic. So for instance, because in previous case it was randomly generated input. So even if you would create like 5,000 different variations, there can be most likely possibility that that value 65 for the variable a will not be tested. So the program will test 100 other different values, both negatives, zeros, positives, but specifically 65 won't be tested. And from the coverage perspective of your code, this particular if clause will not be executed during the test execution. And this is very bad, because like part of your code is not even tested. So in this scenario, or this tool actually looks into different into execution of the code and creates inputs from this, like based on particular execution, based on particular logic. So this is much this is very useful tool in terms of actual looking into different use cases. Naturally, it cannot cover everything, and it cannot like really understand all the different variations of especially some kind of like dynamically produced logic. But even like for the regular usage, this is something that very useful to run and to see how this produces. So our tool for the Solidity is called Manticore, and what it does is symbolic execution tool for the smart contracts. And so, as I said, it identifies an interested code location. So it's not just run randomly inputs, but actually looking into how to actually get to one line or the other. So to create coverage of all your code. So this is somewhat similar to Istanbul tool from the JavaScript perspective, but that one is more like for the visibility, what kind of tool, what kind of lines have been tested and what's not. But this tool is actually trying to deduce how to actually test it and produce the input variables to actually reach these lines. So this is like another level of complexity in terms of code coverage. And what is interesting even more, that it allows full control over all execution. So you can extend it with the Python and different kind of languages. Depends on the API, and so you can actually get to the bottom of every clause of your logic. So let's take an example. So for instance, you have an unsafe addition, and so C equals A plus B. And why is it unsafe? Because you can overflow the C variable, putting two big numbers into A and B. If it exceeds the max UINT, then essentially this creates overflow. And this kind of things that actually create problem for unexperienced developers, because like if you're coming from other languages, these are usually, or especially dynamic languages, these are usually not a problem, as the type is just increased, and this is all done automatically. But for Solidity, it's a big issue, and this is something that is actually a common exploit in the DeFi space, as you're trying to add balances, you're trying to reduce balances. This is from this simple math error, so to speak, you can create double spending. So there is like a variety of exploits that can be only use this feature of overflow protection. And this is why we talked about later safe math library from the Open Zeppelin to use if you have in this arithmetic logic, arithmetic operation. So never use actual plus and minus, but use methods that are intended to provide you the result and do all the required checks. And the other thing is why this is very common in the Solidity like development community, because there is a issue of gas and gas optimization. So as you know, each opcode in Solidity costs gas, and gas is money. So over years, a lot of sort of like overprotective practices have evolved to try to reduce and to make it to make the logic as simple as possible in terms of execution. And people are like looking at every if, and if you need to call another method, then it's gas, so let's not call. So let's copy paste the same logic inside your function, and this creates a lot of anti-patterns from the general program development perspective, and hence a lot of bugs. So as a general rule, don't save on gas. Build your application secure, because if you are going to save this two-way on A plus B, instead of calling the method sum, and which actually will do the same, but also will make some kind of pre-checks, then you save $10 or even $100, but then get exploited for millions. So this is something that's like very, very false economy. You need to build your code as secure as possible, and then if there is an issue of gas, you need to actually look at what kind of how to reduce your gas footprint from the like larger scale, like looking at the whether you save or how much storage you use. So something that actually costs a lot of gas, and not to hunt this one or two GUI here and there and making your code totally unreadable and unmaintainable, and then essentially a honeypot for exploits. So if we go back to this example, we have unsafe addition, so C equals A plus B. And essentially what you need to check, or what the tool will eventually deduce, that you can put max uint into B, and then adding this with A will make an overflow. And from your perspective, from the how do you build the testing for this, is you need to make sure that both C and both C is both less than A and less than B, because otherwise it overflows and it becomes smaller. So once the tool is run, the corrected version would be again like to have like this require C greater than or equal A and B, but again, don't actually implement it. That for safe math, there is a library. Use the library. Pay another 2 GUI for calling another method, and so to make sure that if there is a known exploit even on this or new requirement needs to be checked, then you get it automatically for all your code by using an open source secure library. The next topic that we are going to discuss is reducing the points of trust. And why is this important? Because even if you have the most bug-proof contract in the world, eventually there is a sense of ownership. And what does it mean? And this is again very specific to the blockchain community, to the blockchain development and smart contracting. This is for all the blockchains. It also exists on Solana, so it doesn't matter what blockchain, it exists everywhere. So what is ownership? Ownership is a private key, essentially, or the holder of the private key who deploys the contract. So the person who deploys the contract, or better say, the private key that was used to deploy the contract, is the owner of the contract. And now the question is, who holds this private key? Because if only one person holds this private key, then you don't really need to break the blockchain or to look at the contracts and find the exploit there. You can just send some kind of phishing email to this particular person, and then hack his computer and get the private key, and that's it. And you may be amazed that private keys have been left in the public repositories as in the configuration files. So this is something like, it's an issue by its own. We won't get into how you should store your private keys. This is out of scope here. But we just need to understand that you need to trust no one. You don't, not your employees, not your co-founders, not anyone. There should be a zero trust system in your company, that not even one person, even yourself, can have the power to override your contracts. Because what does happen in the end? Someone gets hold of your private key, the one that has been used for deployment. Or what the hacker does is upgrades your contract to his own, with some malicious logic, essentially stealing, allows to money to be stolen. Then the hack is performed, money is stolen, and then the contract is destroyed. So you don't even know what the logic was for the contract to actually hack, or you don't know anything, and then the money just went away and there's no contract, and go figure how it happened. And then you need to trace the network where the money went, but by that time it would probably end up in some kind of ramp-off solution, and that's it. So essentially, this provides like a holy grail for hackers just to hack this particular person. It also can be an inside job, naturally, as the blockchain is anonymous. Then even your most trusted employee can be essentially the hacker who holds the private key, even while he's working. Even if he has the best conditions and the best salary, he still or she can still hack the system, and no one would even know that it was this person. So this is something that is very dangerous, and how to avoid it. So the way to avoid it is to use multi-signature procedure. And what it does, essentially, it reduces the points of trust by requiring several people, several private keys. It doesn't matter if the actually people are behind those private keys, to make an action, to make a transaction. And this can be government proposals, snapshot vote, fund transfers. For instance, you have funds in your system, and from time to time you transfer to your partners funds. So this is also something that can be restricted to have multiple people involved in actually like signing off these transactions. And as we said, also for contract deployments. So usually how it works, it's called M of N, where we have overall N participants who own the private keys and who can participate in the multi-signature, and we require at least M private keys to actually do something. So for instance, 4 of 7 requires 4 signatures out of 7 owners. And how this is usually done is essentially distributing the power across different departments. So both among the founders, sales team, marketing, like biz dev and R&D, so that people, to reduce the possibility of corroboration, and also to like to enable like this like also to reduce the ownership essentially for any decision. So this is also good for democratization of big decisions in the company. In this case, 4 people need to be hacked out of the 7. So this is much naturally increases the work for the hackers, and makes your overall system more secure. It doesn't make it secure proof, like hacker proof, but it does now require significantly more social engineering. Now that now at least 4 people needs to open your phishing mail, so you need to make even like physical introduction if this is somehow through physical contact. So this is something that is already like on another scale of complexity. It does, of course, come with a cost that if you need to deploy something, now you need to find these 4 people that will actually authorize the transactions. And one is sick, the other is in the meeting, the third one doesn't want or whatever. And so it does create this kind of like inefficiencies in terms of whatever tasks that you have assigned to the multi-sig structure. But this is something that you need to like, I guess, like to cope with, both in terms of company culture, and also if even after that it's still not very comfortable, then this is what it is. It's much more comfortable than getting hacked for 100 million. It also naturally doesn't allow automated deployments or some kind of CI/CD tools, because now you need to an actual signature of actual people. But this can also be like overcome with different deployment settings. So all this can be overcome. You just need to be in the mindset that multi-signature is a must, and everything else is can be worked around. If we talk about tooling, then Gnosis multisig is predominant tool for the EVM world. It exists on every major EVM network, on BNB chain as well. And to go into like more details how to actually do this, there is a site gnosissafe.io. They renamed it recently to Safe instead of multisig, providing more features. But the one that you need is around the multi-signature, and the rest is something that you can look after to see if this is something that fits you. The last part would be that you're not alone, and like it's a twofold, both like it's good and bad, because if you you do interact with different DeFi protocols eventually, and with different bridges, and even if you have been working meticulously on your code and both on your security standards, you still interact with other programs and contracts in the blockchain community that could potentially have not, and as a result have been hacked. And you as a user of these protocols can also be like it's not hacked, but rather like participate in the scheme. Some of your collateral may be used, like if you're putting collateral in the system and then into other third-party system, and it's get hacked and all the collateral is drained, then essentially it's not your fault, but it is your money. So this is something that you need to be aware as well, and how to actually to do something about it. So on the BNB chain, Avenger DAO was created for these purposes. It serves different target audiences, and today we're going to talk about the ones that are interested to us as DeFi protocols. So this is community-run initiative, and was co-founded by different security companies in the field, and the main purpose is to protect the users from financial losses and malicious contracts, and also like raise awareness about the safety and security of different protocols, and deter more malicious actors. The service provides there are three services that are in this like umbrella. The one is Meter that trades the actual smart contracts. So this is more for consumers as they interact with different applications. For them, it is useful to see what protocol that they can trust and what cannot. Watch is something that is interesting for us, as this is a real-time subscription notification about the security exploits in the network. So you as a business will integrate with others DeFi protocols, but not a lot. Like you have a handful or even a dozen, but you are doing due diligence when you actually like sign in these integrations. So from your perspective, this is why Meter is less the case for the businesses, but Watch is, because if one of those dozen contracts that you are interacting as part of your business logic has been compromised, you need to understand and to be notified as soon as possible to shut down your integration with that particular partner, and wait it out, like to see what happens, and even like to verify manually later when things can be reopened. The last one is Vault, is essentially a tool for recovering losses of users that went to not intended contract. This is also more for consumers. And so let's talk about the watch service. So what it does, it's from the architectural perspective, it has different providers of security, both manual and automatic, which scan the system or which can proactively activate it for specific threat, either using some kind of automated machine learning techniques, or people actually complaining, and that first complaint is recorded to the system and then distributed to across the subscribers of the API. So once this aggregator, it aggregates all the like security state, so to speak, for the contracts of interest, and then if anything happens to one of those contracts, then the API call is triggered to the subscribers. So if your system is subscribed to the service, then you would immediately know that some of your partners have been compromised, and you can, as I said, shut the integration down, or even like postpone the whole thing, or at least like take a look at it to understand what is it actually going on, and if is your system affected by the threat. The last part would be talking about how you, as a DeFi protocol or any other project participating in the event, grow together with the BNB chain. So we have several programs around bringing and propping up startups, both from technological and marketing and business development and investment perspective. One is called BNB Chain Innovation Incubator, where we where different companies are being incubated. So essentially, like startup accelerator program, and there are different locations. So this one is around Europe that just has ended a few days ago, but there are different geolocations, both in terms of domain, whether it's gamify or DeFi or anything else, and both in terms of countries of the participants. And usually it's also like the projects are global, so if you have somewhat affinity to any of the countries, then naturally you can apply, and it will be looked at individual case. And the second one is MVB program, which is most valuable business and builders. And this is for a little bit more mature companies around the like actual getting more growth, getting more tractions, getting more deals, business development, working with the others, with other partners within the BNB chain community, and making these introductions, investment opportunities, so things like this. So this is like a second stage, or if you're already at somewhat grown stage that have some traction and market fit, then this is the program for you. And lastly, BNB chain supports a lot of communities, a lot of languages, a lot of communication channels, and 24/7 developer support. This is something that community is always growing day by day. New communities are being created. We have already 13 languages supported, like actual people in the countries with the local development. And so you can either look into those existing communities, or if you want to participate in building or like becoming community leader than in your country, and then you can also do this. Thank you very much for having me, and hopefully this presentation was effective, and if we make at least one of the projects follow the instructions or follow the recommendations, then this already was not in vain.
Perfect. Thank you so much for that, Vic. Now, I did have one question in the chat here relating to will BNB chain, when judging, be looking for dApps that used some of the advancements that you talked about here today? Or, I mean, I guess what participants are wondering is...
So the question is no. So this is hackathon, and naturally this is more around the idea and the most viable product. So we're not gonna be picky around that you have a huge hole and exploit in the middle, but rather around the overall usability and how it's useful. So this is something like from a community perspective, community development as a later stage. And also, so if you want, you can try it out. For this particular event, it won't be a metric.
Perfect. Good to know on that. Thank you so much for your time, Vic, and thank you to BNB Chain. Again, we're excited to be working with you guys during this event, and also looking forward to future events as well. This was the last workshop for Defining DeFi, but I hope that we'll see you again, Vic, at a future workshop.
Absolutely. We'll be happy to join.
All right.
Thank
Everybody
you
have a wonderful day.